One of the things that any home performance contractor is going to want to be able to figure out is what is behind the wall. Normally, you can't see into the wall because of the sheetrock. So what we have here is the ability to look into the wall. Now we can put a blank on this so that it looks like the sheetrock basically. And then the way you figure out what's in there is you could use an infrared camera, or you can use something as simple as this, just a coat hanger. And you would drill a hole in the wall. Now we have some holes conveniently made so we don't have to keep drilling holes. And I can reach in here and determine depth of the wall. I can also visually look in there and see that the cavity has no insulation. If we had a cavity that did have insulation, I can go in with my little hook and pull it out and go, oh, okay, I've got cellulose in this wall, 3.5 inches deep, and now I know what kind of R value is inside of that wall.
In the last episode, we talked about the shape of the house making a big difference on performance. Here is one of the features that we talked about, which is where the upper floor juts out over the lower floor. And this can be a big problem for the performance in a home, which is why in this training center, we can open this up and see what's behind it.
You typically got insulation. You possibly could have ductwork in this area, and you can see back in there that there's no blocking. So air can move from the cantilever back into the home and vice versa. Whereas we want to make sure there is blocking, like in this bay right here, that will stop the airflow.
So in weatherization, we actually use this tool a lot. This is called a blower door. It's a fantastic way to measure a lot of things in the house. The thing that we measure first is just how leaky the whole entire house is. But then once we've done that, we can actually use this tool in conjunction with some other tools, and we can kind of look at different rooms in the house, and we call those zones. This is just an example where we can actually look at the pressure as it changes in each of the rooms throughout the house, and we can kind of see which rooms have more leakage and which have less.
Okay, so right now we're in your mechanical room, and your mechanical room probably has one of these. This is a water heater, what we call a natural draft or atmospheric vented water heater. It has this great big draft hood on it, which is a hole. And if everything's working right, all of the toxic flue gases will go past this hole through this pipe into the outside. But if things are working wrong, all the toxic flue gases will spill out of this hole into your house. So we're going to go ahead and test that right now and see what happens. The way we have the house configured, the flue gases should be spilling out into the house. So the water heater is on. I know this is spilling because I can feel it, but since you guys on TV you can't feel it, we're going to go ahead and show you. You can see all the flue gases are coming back into the house. And they'll continue to do that as long as I let this run. So another way we can tell is I can stick this piece of glass up here, and as the hot, moist flue gases hit the glass, you see the condensation building up on the glass. And we can see that condensation that is built up on there from all those hot flue gases full of carbon monoxide spilling into the house. So the simple fix for this is to add what we call combustion air to the equation. And I can do that simply by opening this door. And now the water heater, instead of spilling, you can see the smoke is now being sucked up and out of the flue where it should go. And if we put the glass back up there, you're going to see there is no condensation building up on the glass.
So here we can see that in just a very small difference in the situation in the house, that we can make something as big as the stuff in the chimney is coming into the house versus the stuff in the chimney is going outside happen, and almost nothing just happened. We just opened a door. So think about how many doors there are in your house and all the different scenarios that you can create with this kind of a scenario. Show us more.
Okay. Your heating and cooling system creates pressure in the ductwork, and the higher that pressure, it becomes a problem. We call it high static pressure, and if you get extremely high static pressure on a system, it can start to cause issues with efficiency and airflow. So right now I've got the system running. We've got our measurements for static pressure here, and what I'm going to do is simply simulate a clogged up filter, and we're going to watch that static pressure start to rise up. So go ahead. Okay, you can see my static pressure or my blood pressure starting to skyrocket. You can hear the blower motor is working much harder, which is not good. It's consuming much more electricity. Our static pressure is getting into a very scary zone where it can actually cause damage to the system. So before the system explodes, I'm going to go ahead and fix that. You can hear the blower motor ramp down, and you can see the static pressure start to come back down.
So the high pressure that you just created by simulating a clogged filter, which a lot of us have, you can actually hear that, if I'm correct.
Yes.
If your furnace in the basement goes wham when it starts up, that is the sound of your ductwork deforming to try and deal with the fact that it's now being sucked on by this giant fan.
Absolutely.
So this is a problem that plagues lots of houses. I've found. Have you found the same thing?
We find it all the time.
I would say about 90% of the places that I've tested, it's obvious that no one has tested this before. So this is always something that I'm trying to, that Wade is trying to get every contractor to just test, just to know. If it's high, you should know it. So as far as the airflow goes, what else can ducts being badly designed or badly installed or being clogged, what can that do to the house? Can we affect the pressures in the rest of the house just with that?
Absolutely. We can cause all kinds of weird pressure imbalances in the house. So
Which is why we have a control panel.
That's right.
Will you show us your control panel?
So we can control the dynamics of the house. We can cause high static pressure. We can cause weird pressure imbalances in the house. We can make things bad and then make them better again. That way our technicians can actually see the problems. So we do this all hands-on and very visual because it's super hard to believe in something you can't see. With this and all the other goodies we have in the house, we can show it to you.